The objective today is to explain the purpose behind the OSI model. So getting one computer to talk to another is tough. The OSI layer model was made as an effort to divide the process of communication into a number of steps, so every step could tackle some of the needed functions of the transmission separately. So in this lesson, I came up with an analogy to help you understand these steps. And remember, they are steps, not layers. I think that was part of the confusion when I was first learning this OSI model. And to add to the confusion right away, I'm already using an orange, which maybe looks like an onion, which has layers. But no, we're going to go through the steps one would take to send an orange from, let's say, Georgia to a place like London, England. So to begin the metaphor, at this moment, you deciding to pick the oranges and send it to the friend is symbolic of the application layer. This is layer 7. So though these things are called layers, think of them more like steps. So step 1 is to pick the orange, it's ready, and we're going to put them into boxes now. So far we have created or possessed the thing to be sent. Now putting them in the boxes is like the 6th layer. Just to create separation, let's say you're not even the one putting them in the boxes. You just picked them or you just grew them, you created them. So you give them to another person, a professional packer, let's say, and he takes your oranges, puts them into several boxes, not just one, fills them with wrapping in order to prevent them from bruising, and then he closes these boxes completely. So now layer 6 is done. What is layer 6's job? And layer 6, this is called the presentation layer. After the presentation layer comes this organizing forklift guy. We're going to call this guy the arranger. He does not know what is inside the boxes, but he knows that they all go to this same friend of yours in London, England. So he labels them appropriately to make sure they get to their destination. This represents layer 5, the session layer. Next up is this guy with the clipboard. He's the checker. He's going to go around and make sure all the boxes are accounted for, make sure he had the right number from the beginning of the process. And if a box is missing, he makes sure to track it down so it can be delivered. This guy is layer 4, the transport layer, which is nice to think of. This transport layer is the guy that's in charge of the moment right before transport. So that's an easy way to think of that. Next up is the pickup guy. So one of the guys from the office actually takes all your boxes along with many others to a post office. So this post office is the 3rd layer. Here it is given an address, the one of your friend, and this is layer 3, the network layer. And I really like this analogy because with this image you see that this post office guy, he has different types of networks on his cart. So in your network where you had your oranges, the post office guy is going to get your oranges boxes and other networks, right? And then they're going to be brought to the next layer, the next step, layer 2. So here we are at like a dock. If you've ever seen a dock in your life, my students here in Colorado Springs, we don't see a lot of docks around here. You have to be on a coastal city. The guys in the dock put the boxes into these containers to put onto a ship, right? They don't care what the boxes contain or where their final destination is. They only care about which other dock the container is headed to. So in this metaphor, I said a dock in Georgia to a dock in London. Again, not caring about the final destination, just caring about the other big idea, the other dock that these containers are going to. So this is layer 2, known as the Datalink Layer. Think Datalink and dock, both starting with D right there. If you're a fan of Assassin's Creed Syndicate, you spend some time on the docks. I thought I'd make that connection right there. So far, think of the big picture. We started with some data, and this is oranges. So we created this data, we grew these oranges, and we want to send them to another computer. So this data is put into a box, organized in a warehouse, checked by a clipboard guy, taken by a mailman to a dock where these dock workers do their thing to prepare the shipment for another dock. By the way, maybe this is where the name Docker came from. In this class, we may never talk about Docker again because that's a little bit higher level than where we're at right now. And I'd be remiss if I didn't take you to this particular blog, some guy named Alex Ellis, where he talks about Docker stacks and attachable networks. I really just took you here because of the really cool pictures that seem to relate to our topic, and not to mention you get to see some code here. So yes, when you're working on programs, you could definitely right there put in some information, transport information into the program. What a cool idea, right? So a good way to think of this OSI model is as a triangle. The size of the data starts up here, and it increases with each step down that you take. So now I'm thinking about the bottom step. The very last step has the most amount of data. I don't think I even mentioned layer 1 yet. What's the last thing you wrote about? A dock? So when it comes to transportation, what did I miss? Can you make that inference? Can you guess what would be at the bottom of the triangle? Is it the dock in London? Make sure you pause right here if you want a chance to try to figure this out on your own. Alright, I've waited long enough, so it's the ship. It only knows where it is headed and takes the containers with it. It handles the waves, those are the conditions of the sea, and the weather, and all these physical conditions, so none of the other layers have to. Like, that's the ship's job. That's layer 1's job. This is known as the physical layer. Physical layer is only concerned with the wires, the radio signals, the physical way that the data, the ones and zeros, are transported from one place to the other. So to figure out how your friend opens up your message or whatever, like opening up the box of oranges, all you have to do is reverse your steps. So think about this. If I am on my Xbox and I'm downloading a game, I make a request to download the game. So the person, Microsoft, or whoever created the game, had created this program file, and now it's going to go through all those layers, and when I go to download it on my end, it's going to go back up through those layers until I get to the data that I care about, the game that I care about. I wonder if you can do this yourself. Like, can you do this without looking? Like, read your notes. Go from the beginning at the dock in London to the top where your friend opens up the box. So here's my rough attempt at doing that. So the ship gets to the port in London, the containers are picked up off the ship, they're opened, and those boxes, those containers are given to this delivery guy, who then brings them to this warehouse where there's a checklist guy to make sure all the boxes are there that are supposed to be there. And then this forklift guy is picking up the boxes and putting everything in order. Finally, you have this arranger guy, he opens up the boxes. And here your friend is maybe at that warehouse because the boxes never left that warehouse. You have the guy who is there at the warehouse opening up the boxes and picking the oranges that he wants, or seeing all the oranges being the data, having access to all of that now. Man, metaphors are rough, but I like them. 2 big points not to forget with all that craziness. Each layer can only communicate with the layer on top or under it. So the physical layer is not ever really relating to the application layer, or directly influencing it, I should say. And then each layer only fulfills a specific role. So that role is reciprocated by the same layer on the other side. If you're confused about my pictures here, this rapper has a song called 2 Points. So that's his music I had found when I was watching Luke Cage, and it's like some really good stuff if you like that kind of music. So this is the very professional way to look at the OSI model. Take whatever notes you want right here. And for my students who went with me through the computer science class, a lot of these protocols and other things you're going to understand. You should know HTTP. You know what a JPEG is and a PNG type file is. And maybe this is a little confusing. The session layer took me a little bit of time to really wrap my mind around. But you know TCP. You definitely know IP here. And as a reminder, MAC, that is the physical computer's address, not the IP address, but another address that a computer is given by a manufacturer, and they're all unique. And going down here, data encoding, you know the concept of encoding in the sense that there needs to be a very specific permutation, a very specific ordering of bits to have different meanings. And at the physical layer, we could be talking about light beams or, light. We could be talking about radio frequencies, those waveforms can represent ones and zeros. Or if two computers are connected by an Ethernet cable or a Cat5, Cat6 cable, then the physical layer could just be those wires. So with the professionalness in mind, here's your DOL. It's a very unique one. I want to go through each actual layer, like the definition of each layer, and I want you to explain why it's just important to know about, like just period, knowing about it in a networking class like this one. So here we go. The physical layer is responsible for the transmission and reception of unstructured raw data between a device and physical transmission medium. The word medium being like the air, a physical wire, or light. It converts the digital bits into electrical, radio, or optical signals. Like these can change throughout the entire transportation process of data. If I'm here in Colorado communicating with China, I'm thinking there will be several different mediums that the data goes through. So DOL question number 1, no surprise you'll have 7 of these since there are 7 layers in the OSI model. Question number 1, why is this layer an important layer to know about? DOL part 2, why is this one important to know about? It's called the Datalink Layer. And notice we're going in reverse order from how we started this video. So the data link layer provides node-to-node data transfer. This is a link between two directly connected nodes. It detects and possibly corrects errors that may occur in the physical layer. So it defines the protocol to establish and terminate a connection between two physically connected devices. We could be talking about my computer to my modem/router, and then from that to whatever the ISP is using to transfer my data. And then again from that node, from whatever the ISP has, to the server that I'm looking for, which is another node, and so on. Here we go with DOL Part 3, the network layer. This provides the means of transferring variable length data sequences called packets. So remember, variable length is just changing in the amount of bits we're looking at. So it's providing the means for transferring these data sequences from one node to another connected in different networks. So not surprisingly, network layer is all about one network to another network. Why is that important to know about? Number 4, just to be weird, this is my favorite layer. I really like the transport layer the most. So this transport layer controls the reliability of a given link through what's called flow control, segmentation and desegmentation, and error control. So some protocols, you can choose different types for the transportation layer here. These protocols can be state and connection oriented, which means that the transport layer can keep track of the segments and retransmit those that failed delivery. The transport layer also provides the acknowledgement of the successful data transmission and sends the next data if no errors occurred. The transport layer creates segments out of the message received from the application layer, so segmentation is the process of dividing a long message into smaller messages. So why is it my favorite layer? Maybe because of this word acknowledgement. It's all about acknowledgement. Stay strong here. We're almost done. We're at layer 5 now. This is the session layer, and simply to state this simply, it's the start and the stopping of the transmission in the first place. So a great example to think of is like a telephone versus a walkie-talkie. On a phone, you could call somebody, and this creates a session. You are connected with them whether someone's talking or not talking. But with a walkie-talkie, like you can click the button and say something and just hope that that person on the other end is listening at that exact moment. There is no session created with walkie-talkies. The session layer creates this moment where one computer is waiting to hear back from another computer. Now this analogy I did not come up with myself. I got from Computer World, an article in Computer World, and it's a pretty good one once you get past all the insane amount of ads. But I did take you to this site because I wanted to give the author credit. Guy named Josh, it looks like, Josh Stevens, but I wanted to give him credit because, in case I'm wrong right here, what he says and what I think is true is that of the 7 layers of the OSI model, layer 5 and 6, the session and presentation layers are the 2 least relevant layers for network engineers. So I'm a big crypto guy. I like cryptography. So what that means is the presentation layer is not the least significant to me because this is where the encryption and decryption is going on. But I could totally get why a session layer would just be not relevant to a network engineer. But I'm not a network engineer, so I care about the presentation layer. Don't care about the session so much, but presentation is interesting to me. All right, so that means the presentation layer is the sixth one, and tell me why this is important, please. What I'm looking at is the lowest layer for application programmers, and this is regarding their consideration of data structures and presentation. So not surprising right there. This layer deals with issues of string representation, so we could be talking about ASCII, and the concept of compressing and decompressing stuff, data. If you're the sender, you might compress it and then send it, and you're the person opening up the box of oranges. You're the person opening up the application or downloaded software. You're the person decompressing. And same with the encryption and decryption idea. Why is the application layer important? The application layer is the OSI layer closest to the end user, so which means both the OSI application layer and the user are interacting directly. It's the only layer that your average person is working with directly. So what a great and creative lesson on my part. I tried to be creative with teaching the OSI layer and then just giving you an opportunity to make inferences as to why each layer is important. I love these IB concepts, so though we're not in IB class, I still think you should consider like what this lesson can relate to. So fill this blank in if you'd like. And to end here, I don't want to troll you guys very much, but after I had created the lesson and gave you those inferencing opportunities as to the importance of each layer, I was thinking that at the end you could have just said the exact same sentence for every single DOL opportunity. You could have said that now, knowing about that layer, whatever layer it is, 1 through 7, that knowledge would be helpful in case you have a problem sending a file from one computer to the other. So if you're trying to troubleshoot the problem, why somebody can't get something, you would probably take a look at each one of those layers to solve that problem. And if you're not a skilled network engineer, then you're not going to be focused on layers 1 through whatever it was. What was the session layer again? 5. You're not going to be looking there if you're not the network engineering person. I hope you don't hate me too much for that process. For the students in my class, thank you in advance for catering to my creativity.